In a previous video, I looked at how we can build software for capturing video and performing image processing on the Beaglebone. I showed how we can capture video, capture image frames, and use OpenCV to perform image processing operations under embedded Linux. The previous video is linked here, and if you want to understand exactly how I performed the tasks in this video, I would recommend that you watch that video too. This video extends the previous video by looking at video streaming on the Beaglebone Black. I have managed to get a few different types of video streaming working using the capture program that was discussed in the previous video. So this video will discuss video streaming using RTP, which is real-time transport protocol, UDP unicasting, which is user datagram protocol. Now most RTP implementations also use UDP, but they also have some high-level functionality. For example, identification of the payload type, synchronization of multiple streams such as video and audio, and so on. And finally, I look at UDP multicasting, which allows for one-to-many type connections. In all of these examples, I'll use VLC Media Player to display the video data. The final part of this video goes on to describe how you can build your own software implementation that can display the data. The advantage of using this is that you can add your own data processing and controlling functionality into the video display. You could even develop code for capturing multiple streams simultaneously and processing the data, for example for stereo imaging. This video is really a demonstration video. The actual technical details of each of the stages is discussed on my blog. Each section will link to the relevant blog entry and you can find further technical detail there. Okay, so here's my setup. I have my Logitech C920 here and I just have my Beaglebone. I'm using that as a subject of the video. You can see it's connected via USB and that I'm powering the Beaglebone with a 5-volt barrel jack, and it's connected to my network into a regular switch over Ethernet. So on my desktop, I'm within my virtual box and I'm just going to use this just to talk to the Beaglebone, just to be very clear. So I'm going to SSH into my Beaglebone, 68.1.81. I'm logging in as root. Okay, so I'm in my Beaglebone directory and I'm just going to clone the source from my repository. So git clone git github.com/DerekMalloy/bonecv. You might have to use .git as well, but it seems to be okay. So I have my directory. Go into my bonecv directory, and you'll see that this is the version I used before. I've added in a few scripts. So this is the bonecv computer vision and the tools such as capture for capturing an image stream. And all I've done is I've written a few scripts around this with help from others. So the one I'm going to work with first is the RTP. So I'm going to start this up. So /stream video RTP, and you'll see, just check the contents of it first. And just make sure it's okay. So you can see that the effect is I'm running the capture program that I discussed in the last video. I'm forcing it. I've changed the code slightly so that -C0 just means an infinite number of frames. I'm running this into AVConv or FFmpeg. It's well, more or less the same. And RE means that we're reading the input at the native frame rate, which is around 30 frames per second. -I- was tricky to find, is to take the input from the pipe, so that means it's coming from capture. Vcodec copy, that's coming from, it means that we don't transcode the video. This C920 outputs in full HD, so we just want to use it. We don't want to transcode into another format. That would be overly taxing on the Beaglebone. -F then says that we are forcing it to be sent to an RTP stream. So we're forcing RTP output, and we're directing it to my computer, my PC, which is on 192.168.1.4, and chosen at random we're using port 1234. So we'll execute this and we'll see /stream video RTP, and that goes off. And you'll see I discuss in my blog how to generate the file that we need from this, the SDP file, effectively you need to copy this contents here into a file. So I've done that already and I've transferred that file as I did in my blog. I'll link the blog to the video here. And these contents describe the stream. So they describe that it's going to be an input IP4 stream. It's going to be sent to this address, and it's going to come in on port 1234. So on my computer, I have a file, Beaglebone RTP stream.stp. So I'm just going to open this. So I just open this stream. I just cancel for a second. So I'm within my VLC media open file. So on my desktop, it's called Beaglebone RTP stream.stp, and this is what happens. So we get a stream, just change the size a little bit so it fits on the video. And initially it's corrupt because it has to get the frame. So you can either leave it and it'll find the keyframe, and then the video quality is good from this point on. So you can see this is live video that's coming from the Beaglebone camera, and you can see that as I move the camera around a little bit, you'll see that there's delay, but you'll see that clearly it's live video. Now I'm capturing this video with Camtasia, so it probably doesn't do it full justice. It's got a very good frame rate, and you can see there's a delay because if I move my hand, I have the video synchronized. So I have a video of a video. If I put my hand in front and take my hand away, you'll see there's a slight delay in this happening. Over here, just minimize this a little bit more, you can see it working away. So you can see, just pop VLC back open again. You can see that it's running frames 3000 whatever, it's 30 frames per second. The size is that, the time is that, the bit rate is around 3 megabits per second, which is very good. So that's my RTP stream, and it's working very well. It's good quality. If I'll maximize it. Let's just maximize it within the frame for the video record, and you can see that that's too big. Try again. I don't want to make any bigger. So you can see that it's a good size quality frame. It's not bad. I'll put my hand in front of it so you can see the change. The camera has an autofocus, so you can see it comes into focus. If I let it go again, take my hand away, you can see it goes back into focus again. So it's a good quality camera. The light is a little bit dark here at the moment, so you can see that maybe it's clear. You can see the lens has an active element in it, so it's working quite well. So you point at the monitor it's in, you can see the delay. If I put my hand in front, oh, that's not bad, that's very quick. Delay is quite small. Try it again. Let's see if I can measure the delay. So it's not the delay here. I suppose I'm on a local network, but you can see there's a very small delay between the two, and it appears to be quite effective at taking in, encoding the video and sending it out. So if I kill this stream, we can also use the UDP. Okay, that's the right address. So we can stream this using UDP, and the advantage of this is that within VLC we don't need the file anymore. It just means we can open it up directly. So we can go Media, Open Network Stream, and we get our pop-up box here, and we can open and we can say UDP:// @ 1234. That's all we need to know. So effectively, it's a little bit strange. Again, remember this is the Beaglebone. And this is the program running on the Beaglebone, and it specifies the IP address of the viewing machine, and that's a little bit strange, but that means that on this machine effectively the stream is being sent to us at port 1234. So we just open up UDP at 1234 and we can just play this directly, and there we go. You can see that stream is not yet working. Okay, give it a second. Now So you can see there's a slightly bigger delay on this stream at the moment. In fact, it's a massive delay at the moment. There we go. It's jumped itself. So we're back up to about a 1 to 2 second delay. Just to put this, I'll put my hand in front again just so you can see, and you see the delay. So it's a larger delay on UDP. I've noticed that consistently larger delay on UDP, but it's useful in that you don't need to distribute the configuration file to the stream, and you can see the quality to the viewer, and you can see the quality is very good too. It's just as good with the camera, so it works very well. No issues with that. The other way we can do this, I'll just hit stop, hopefully that'll work. Another way we can do this is to use multicast, and multicast is effectively, we specify, you have to find the multicast address for your network, and you can see that on my network I'm using UDP, and I'm saying that again with my UDP I said that it's within a MPEG transport stream. I'm using UDP 226.0.0.1 at port 1234. Now the advantage of this is that we can view this on multiple computers at the same time. So multi-stream multi. So it starts up the same way as before for UDP. And we can open it up, we can open up VLC, and we can open the address directly. Open network stream. Again, this is on my PC. So it's at, and the address is, you can see it here, 226001. A mistake there. UDP 226 at 226001. Okay, and there we go. We've got our stream, and to see the effect of this, again, you can see it's taking time for it to kick in, and it's out by about the same, by about 1 to 2 seconds. Put my hand in front. Oops. Oh, it's not yet. Hold on. Now it's out by 1 to 2 seconds. Hand in front, hand away. Okay. So it just seems to, after a little while, it just seems to synchronize a little bit more closely. I suppose that's the benefit of UDP, is it will just throw away the data. Okay, so that's the network stream, that's multicast. Now the benefit here is if you've multiple computers, I don't know if I can open up, so I'm going to open up a second instance of VLC, open network stream, and I can open at 226.0.0.1, and you can see now I've got a second stream. Now it doesn't really matter, you can see hopefully this is 2 streams from the one. I'm playing it with 2 different players, and if I just reduce the sizes down, you can see hopefully they'll synchronize a bit, and as soon as they there, so now they're synchronized. So let me try and move my hand in front of them. So effectively this could be this is multicast, and this is showing that multicast is working, because we wouldn't be able to do this with a unicast with 2 different streams. You saw that we can hand in front. You can see that both streams are perfectly synchronized, and I've tried this on different computers on my network and with my laptop, and it all works perfectly. So I do have real multicast happening on the network, and you can see that it works very well. So that's a useful feature. Again, the quality is preserved and everything's synchronized. This would be very good for robotic applications where you want to have multiple viewing outputs. Okay, so that's covered the different setups. So you can see on my blog I've covered UDP, unicast, multicast, and streaming video using RTP. So I've covered those topics, and we're using effectively the capture program that's been sent into FFmpeg, MPEG or AVConv, and then I'm using VLC as the player for playing this. Now it is a little bit restrictive to be playing the video into a media player, because it may be the case that we want to do something with the data, such as process the data or use it to navigate a robot, for example, where we want to have controls. So playing into a player is a little bit restrictive. What I want to do now is to look at different alternatives on how we can actually capture this data stream within an application, a remote application that's different from, that's away from our Beaglebone. And to do this, I've looked at a few different options. I'm just going to kill this so that it doesn't get in the way. And two that have worked very well for me, well, the first one is one called VLC Wrapper. And effectively, it uses libVLC, and I've managed to build this using Visual Studio. And it works perfectly. The way it's set up here, it looks like it's for playing local files, but you can also connect using your SDP file and connect to the stream, because it is using VLC to do that. So VLC is taking care of that behind. So for both of these applications, you need to download and install VLC and the developer version. So that's available from download.videolan.org/pub videolan VLC. And I'll go through this in my blog, so there's no need to spend too much time on this. But you can see here the different versions of VLC for Windows, and the libraries are there. So VLC Wrapper wraps those libraries and allows us to build applications. So here, for example, I've built this for my for just to show it running. So here's my VLC dialog demo. It's the code from that website. And you can see within the README, there are a few steps you have to go through. You have to go and copy all the plugins. Now, the plugins directory is really important. That's full of DLLs, so you have to make sure that's present. This one uses Lua, and you need to have your libVLC core, and you'll get those and then run it. And it works straight out of the box once you do those things. So here's VLC dialog, and you can open a file with this, and the file I'm going to open is my RTP stream, my STP file, which was the same one as I used earlier. And you can see when we open this, it'll allow us to connect to the stream. You get the same blocky effects. You can either put your hand in front of the video to clear it. I've nearly cleared it, or you can just wait till it goes to the next keyframe. So you can see here, this is the same quality as we had with the VLC player. It's the same. It's the exact same thing. We've just encapsulated it. But obviously this would allow us then within Visual Studio. I have built this using Visual Studio. It does allow you to add controls and to add new features to the stream. It would also allow you to have multiple displays and so on. So I found VLC dialog works very well. There is another option and this is the one I preferred, and I'll just open it up in the website. I'll talk about how to set this up. It's VLC Qt, and I like Qt because I think that it's a very good set of libraries to wrap around C++ that work very well. And this projects.tano.si provides you with the download for a wrapper for VLC within Qt. So you download that and you end up with a project. Just get the project. So here's the project, VLC Qt. And you can see that you have your source with all the source for everything to do with the library. You have the library, the DLL for Qt widgets and libVLC Qt. And it also comes with a couple of demonstrations, the include for the include files for all of these. And it's a lovely wrapper because it has all the functionality that you would want to break out to control the video stream. Within this, I've built, and I'll just show you the Qt project, the demo. So here's the demo that was built. Again, all credit to the author. It's nothing. I'm just had this working. Just make sure, and I'll talk about this in the blog, that you set up your libs and include path to where you have the library. So -L and then the path for where the libraries are, and that you want to include Qt and the widgets. And also, if you're using a new version of Qt, that you need to include the widgets library. So you also have the include path. So with this here, we can execute this. This allows us to build our demo player. So I can change this to stop stream, And Qt allows us to do things like this, and I can call it open local file, open URL. For this, I'm just going to show it with UDP or multicast UDP. So I'll kill this, and that's a stream multi. Like my Qt project back open again. And again, you have to be a little bit careful with this, and I'll go through this in the blog on how I set it up. But you have to make sure that when you build this, I have my build, you have to make sure that in your release directory, or in this case my debug is my release, I have to place my libraries and the plugins folder. Again, that's very important because you'll see in here it's all DLLs. So you either have to have those in your path, or you have to make them available for the code, otherwise it won't be able to find them. So that's my libvlc, and it's present there. So within that directory, I have my build, so I can just simply go out here and execute this directly. Again, this is on my PC. So it builds it, and there's my application. There are a few errors that I haven't tidied up yet, but you can see that it is tying directly to libvlc, and it's using version 2.002 Flower in this case of VLC. So in this case here, I can minimize the Qt environment, and you can see I'm running again on 226.0.0.1 port 1234. So I'm going to open that URL. That should have popped up over here. UDP : / at 226.0.0.1 port 1234, and open it up. So I've just renamed it just to show it. But again, this is now has full access to the multicast, and you can see that I can stop the stream and I can build controls, and you can see I called stop stream. So it gives us full control over the user interface within a Qt environment, which is a really good way to wrap code. There are other examples where you can have multiple streams open at the same time that are made available. So there's plenty of source code there to work with, and it's a great library. And I highly recommend it. It works very well in streaming the data. I can put my hand in front of the stream so you can see that it's a live stream. And there are other applications that come with that as well. So it works very well, and I'd recommend it as a good container for VLC, so that you can build your application to control your robot, to record your video, to have multiple video streams for stereo, or many streams for vehicle applications, or whatever type of applications you need.